This video will give you an overview of the contents and structure of Assignment 1A. The purpose of this assignment is to give you experience using Android Studio to develop and test a Java array class. Although we'll be using Android Studio, the code you write for this assignment will not have a GUI and will not run as an app. It's important that your array implementation work properly, however, since it's required by all subsequent assignments in this course, including the ones that are Android apps. Before you get started, you'll need to do the following things. You need to download and install Android Studio. You can find instructions for doing just this if you go to this link from the CS891 website. Likewise, you'll also have to set up your account on GitLab, which is also explained on my website here under the Installing Software link. An array is an abstract data type, or ADT, that's implemented as a single contiguous buffer that provides various operations like get, set, add, remove, and size. Your task in this assignment is to implement a generic array class in Java that can be parameterized by various user-defined types. This class will be different from Java built-in arrays in a number of ways. For example, it can be resized. It can also be used in conjunction with other Java collection framework classes. Grad students who are taking this class for grad credit must do the following additional work. You'll have to implement the requirements of the iterator interface, which we'll talk about shortly when we discuss the skeletons. As much as possible, try to avoid using loops in this assignment, and instead try to use the arrays copy of method. This isn't possible for all parts of the code, but try to use it wherever possible because arrays have a number of accidental complexities that can cause problems. There's a number of resources that can be helpful in completing this assignment. There's the Java Utils Arrays documentation that explains how to use the copy of operation. And there's also a tutorial at the Oracle website that describes how to use Java. If your knowledge of Java is somewhat rusty, I recommend you watch the videos in our Coursera Java for Android MOOC, which you can subscribe to freely and watch to bring yourself up to speed. There's some skeleton code for this assignment, which is available here in my GitHub account. If you take a look at that link, you'll find the various directories. You'll also get instructions on how to clone this directory and make it part of your workspace. Once you've set up your GitLab account and you can pull the skeleton code into your repository, read the skeleton code carefully and complete the to-do markers. If you're an undergrad student, please use the shells that are in the ugrad directory. If you're a graduate student, use the shells that are in the grad directory. We'll come back and take a look at that code in just a second. There's a number of unit tests in either the ugrad or grad directories, and these are provided to help you see that your implementation is working as expected. You'll need to set up Android Studio to run the JUnit tests locally. Even though we don't have a GUI, you can still use the JUnit tests via the Android Studio GUI as described here. There's a little description about this. It's pretty easy. I'll show you how to do it in a second. And as usual, keep in mind that testing only indicates that bugs are there. It doesn't demonstrate that the bugs are not there. So you can't rely solely on testing to detect all the problems in your code. You have to think carefully about how it works, look at it, analyze it, and of course I'll be providing you with feedback when I do my review. This assignment is designed to be easy to implement. The goal here is to get you up to speed using Java 8 and Android Studio. The first version, Assignment 1A, only uses Java 7 features. The next version, Assignment 1B, uses the Java 8 features. If you find it really hard to complete this assignment, you may not be ready to take this class. And if that's the case, please talk to me as soon as possible so I can discuss various options you'll have in order to do things. And we'll get you on your way as quickly as we can. We'll now switch over to Android Studio, and I'll walk through the skeleton files that I provided for the undergrad and grad versions of the code. This is the ugrad version. As you'll see, the grads implement all this code plus some more. Here we have the various files. We've got the array class. That's what is open here. We've also got a test class that's over here that'll be used to test the code. You don't have to actually write that code. That's what you will use to run. I'll show you how to run that in a little bit. Here's the array class itself. As you can see, it's a generic class. It's parameterized by elements of type E, which is just any type that's a user-defined type in Java. The array class implements iterable. We're going to need that in order to be able to do the iterators for the grad version. Down here, we can see some of the fields that are defined. We have an array of objects called melement data. And we have to store these as objects, even though they're going to be elements of type E because of some of the quirks of Java generics. Here is an int that is the index to the last element in the array. This is used so that the add operation works efficiently. It always sticks the element that's going to be added to the end at the end position after making sure there's enough room for that. We also have another field that is used to count the number of elements in the array, which may not be the same as the end if you start removing things. There's an initial capacity, which defaults to a size of 10. We'll talk a bit more about how to implement that shortly. There's an interesting final static field called sEmptyElementData that's an array, and that's used down here as a placeholder to do some clever initialization, which we'll talk about shortly. Here's the implementation of the array constructor. As you can see, it simply sets element data to be this empty element data, and that will actually be used as a flag in a later operation in order to be able to allocate the default number of elements without allocating any memory at all until the array instance is actually used, for example, by calling add on it. Here's the array constructor. You have to implement this. This needs to do a little sanity check to make sure the initial capacity is not a negative number. If it is, it'll throw an exception, and otherwise you go ahead and initialize it to the appropriate size. You'll initialize the element data to the appropriate size and any other fields that need to be given a value. Keep in mind that by default in Java, fields are given default values. So an int is given a 0, size is given a 0, and so on. Take a look down here. We see a method that will take a collection and then it'll create an array from the collection. The collection could be any type of collection in Java. It could be a list. It could be a set, and so on. And so there are operations that are defined on collections in order to be able to iterate through them and take the values and basically initialize the array from the contents of the collection. Not too hard to do. You just have to sit there and think a little bit, take a look at some of the documentation about what collections are. The isEmpty method is very simple. It's just going to return true if there's nothing in the array. The size method, also, it's a simple accessor. It just returns the number of elements in the collection. Should be pretty obvious how to do that. Index of is a little bit more interesting. What that's going to do is it's going to take an object and it's going to search through every element in the array from beginning to end, trying to see if there's a match. And if there is a match, it'll return the index where the match occurred, the index into the array. If there's no match, it'll return -1. Now keep in mind, this code has to work properly even if object is null. So you need to check, you'll have to have special case checks to see if object is null. And that's a little bit interesting. It's not hard, you just have to keep that in mind. Here's the add-all method. The add-all method, there are two methods that do add-all. One takes a collection, one takes an array. The one that takes a collection, again, could take a list or a set or any other kind of collection and use the various means that are provided by collections to add every element in the collection to the array. And likewise, here's add all that takes an array. And this, of course, is going to use an array, and it'll go ahead and do adding each element in that array into the collection. Into the array. My recommendation is to make this simple and reuse other methods in the array class to implement add all, either with a collection or add all with an array. Here's the remove operation. It removes an element at a specified position, so at the index. Obviously, if the index is less than 0 or greater than the bounds, it'll throw the index out of bounds exception. Otherwise, it'll go ahead and remove the item, and then it'll go ahead and shift the elements down. Now, this is a good example where it really pays off to use like the arrays copy of method rather than trying to do a loop. So I recommend you take a look and figure out how that works. Here's the range check method. This is an important helper method. It's a private method. You don't call it directly from the public client interface, but it's used by a number of the methods internally. And it just makes sure that the index is within the bounds of the array. In other words, greater than or equal to 0 and less than the size of the array or the number of elements that are currently in it. The get method is what's used to return an element that's at a specified position in the array. Obviously, the array will have had to have been initialized for this to work. If there's nothing in the array or the index is out of bounds, you throw an array out of bounds exception. Set, likewise, will go ahead and replace the specified element in this array with the element that was defined here. Keep in mind, of course, that once again, the array will have had to have been initialized, and you'll have to have backing store there before you can do a set. This is a little quirky aspect of Java that's always thrown me for a loop when I didn't quite expect it. Set does not work if the array doesn't have an element at that position already. How do you get elements at positions? Well, you have the add method that will add the element to the end of the array. And this, of course, has to do range check. So you have to make sure that the index is in bounds. And well, maybe a better way to put it is you have to make sure that it's not going to be less than 0. Range check doesn't actually have to be used for add. And the reason that range check does not have to be used for add is we're going to use something else called ensure capacity internal. And this method is what's used to make sure that the array grows to be big enough to add the next element into it relative to whatever the end of the array is. You always put the element at the end. In other words, that's what mend is for. This method is a little bit tricky. You have to think it through kind of carefully, and you have to make sure you call ensure capacity internal to do some of the work. Now, ensure capacity internal is got two purposes. One is to be able to resize the array if it's not big enough to hold this item. And it also has to check for the first time the array is accessed. Because remember, if we go back up to the constructor here, you'll see that the constructor, which is defined up here, by default, the default constructor just sets this sEmpty element data field to melement data. So you'll have to have a special case check within this method, within the ensure capacity internal, and allocate the initial default size the first time in. And of course, you'll have to make sure that that's big enough to store the element that you're trying to put to. Here are a couple helper methods that you may find useful. I found it useful in my implementation. This is a method that returns a copy of an array. So it makes a element by element copy of an existing array up to m size elements, and it returns a copy of that as an array of objects. So that's one helpful thing. And then there's another interesting method also called toArray that can be used to work for arrays of elements of a particular type. And this does some other cool things using arrays copy of and system.arrayCopy. So I urge you to take a close look at this code and make sure that you understand how it works and what it's doing. It's really cool. Read the documentation, look at the code, play around with it, get a sense of how it's going to be doing what it does. And then for the undergrad version, the iterator is simply going to return null because there's no test for the undergrad version of the iterator. That's only for the grad students in assignment 1A. We're now in the grad student version of the array class implementation. Pretty much everything here is the same as the undergrad version. The main difference is that you'll have to implement the iterator. So let's go down here and take a look. Here is the factory method that will return an iterator. So you have to go ahead and fill in how to do that. It's quite simple. This is what you'll be implementing to implement the iterator. The class, surprise, surprise, is called array iterator, which implements iterator. And down here, you can see that you have to fill in the various fields. You have to keep track of the current position in the array, which, by the way, will be accessible because of the way that inner classes work in Java. So the array iterator instance will have access to the array that it's iterating over. And so you'll have to keep track of the current position and the index of the last element returned, which is in order to implement the remove method, as we'll see. And then there's a couple methods you have to implement. You have to implement hasNext, which will return true if there's still more elements to iterate over in the array. Otherwise, it'll return false. You also have to implement next, which gives back the next element in the iteration. And this will throw the index out of bounds exception if there are no more elements to iterate through. And then the final method, which is really the only one here that's even the least bit tricky, is the remove operation. And this will keep track of where you are in the iteration. And if you call remove, it'll remove the element that you were iterating over. And you can only call this method once per call to next. Otherwise, bad things will happen. So that's basically what the grad students have to implement, just do a little bit extra work. And then in the next assignment, in assignment 1B, the undergrads will have to implement these iterator methods as well. And the grad students will go on and implement something else called a splitterator. But we'll talk about that later. Okay, so now that we've looked at the skeletons for the grad and the UGrad version, I'm going to show you how to run the unit tests. These are the unit tests. They're a little different for grad and UGrad, but they're all doing more or less the same kind of thing. As you can see, what they're doing here is they're going to be exercising various methods that are defined in the implementations, checking to make sure that they're working correctly. If you look at this code, you can also kind of get a hint of the semantics of what things are supposed to be doing if you get a little confused about what an array is supposed to do. I'm not going to walk through all the code here in great detail. Just be aware that it should hopefully test all the common problems that can arise when you write your code. So what you'll do is you'll go ahead and open up the all tests element in the Android Studio program, and you click run on that. You'll right click and then you'll click run, and it'll go ahead and build. And then as you can see here, it went ahead and it ran all the tests. This particular example runs all the grad tests and the undergrad tests. If you're just running the undergrad version, of course, it'll only run the undergrad tests. The main difference being the test iterator is for the grads, not the undergrads. In this particular case, my implementation worked correctly. So as you can see, all the tests were green. If you have bugs in your code, then of course, something will come up red and it'll tell you, hopefully with a relatively useful error message like an exception or some other diagnostic, what went wrong. And then you can go in and try to figure out how come your implementation has a defect. So unit tests are very useful to learn how to write, and we give them to you here. Maybe later in the class or some other classes at Vanderbilt, you'll learn how to write unit tests, but they're incredibly helpful to make sure that your code doesn't break, that it works and it doesn't break. Be aware, of course, that the testing is only as good as the unit test implementation. So if I forgot to check for something important, then you might have a bug in your code, even though it passed the unit tests. So you still have the responsibility to look at your code carefully to make sure it works properly. And I may, of course, add additional checks to the unit tests over time as I discover weird problems people have in their code that my test didn't cover. So that's basically an overview of assignment 1A, and hopefully you'll be in a good position to come to office hours and ask questions on Piazza to get more information.